Well, welcome everyone, and thank you for having me here in Stanford, a really amazing building. Um, I will talk about how do we actually ensure trust in the systems we're working with, privacy and user ownership as kind of AI evolving. For those who are not familiar with me, before kind of jumping into the blockchain rabbit hole, I was working on AI research. I was at Google Research working on natural language understanding, machine translation, and I was on a team that developed the transformer technology, which is powering all of the modern AI evolution, the T in GPT. I then left Google because I wanted to use this technology in a product, and I really believe that if we can teach machines to code, to write software directly from natural language, we effectively can change how we're going to interact with computing. Now, in 2017, that sounded like a science fiction and delusion, and so and it was a little bit because we didn't have compute yet. We didn't have enough kind of scale to do this. We were trying to actually collect a lot more training data to really train our models. And we had a lot of computer science students actually from Southeast Asia, China, Eastern Europe, which would do small tasks for us. And we had challenge paying them, right? Every of these countries have some kind of monetary restrictions, and that's how we got into blockchain. It's like, hey, blockchain is this global payment network that can really move assets and money around. And looked at Ethereum and Bitcoin back in 2018, and even back then the fees were higher than what we were paying people, and so we kind of started digging in. Is like, why is it so expensive? Why it doesn't scale? Why is it so complicated to develop on? And so that's kind of how Near started. Really, how do we solve billions of users using this every day at scale in a way that doesn't require everybody to understand the underlying technology? Now, obviously, since then, world continued evolving, and I think the thesis that we, had with Near AI back in 2017 is now very much so real, right? The AI is becoming the platform that everything else has been built on, right? We have Nobel Prizes in chemistry and physics are now given to AI researchers. We have, even mathematics and every other science has been kind of now augmented with AI. We have effectively every day-to-day from school to business operation are effectively being supercharged by AI. And so the reality is, from my perspective, this is how we're going to kind of communicate with technology going forward. Will all be through AI, and potentially beyond that, kind of how we're going to communicate with the world. And so whoever controls this medium, right, whoever controls this tooling is effectively controls everything. This is akin to AOL being the internet back in the 90s, where effectively you had one company controlling how you can communicate with anybody else and can kick you out at any point of time. So it's extremely important that kind of we understand what is the control here. And we have right now effectively a duopoly of state, right? We either have a closed source AI companies, right? Some of them are not far from here, that are offering state-of-the-art models, but they are very much centralized for profit, and they effectively have control over how you can access this, what you can ask it for. And again, they're not doing this from evil will, but they are a business. They have a very specific regulation they need to comply with. They also don't want to get sued, so they're going to restrict a bunch of stuff that potentially can get them into trouble. And on top of this, they have a very massive control where it can decline to provide service to anyone on any level, right? So this is, for example, in Hong Kong and even in other countries, OpenAI just doesn't provide service, right? And so you can effectively have no access to what becoming the most important tooling in our world in the whole country. Now, we do have open source, which is amazing. There's been a ton of development on this. But the problem is open source is unsustainable, right? There's kind of time and time company would release it, raise money from VCs, build a model, release it, and then make no money on it, and effectively end up stopping doing that and becoming either a closed source provider or running out of business. right? So the reality is open source right now does not have a sustainable business model. Kind of the only wish that Meta continues open sourcing is obviously a very hopeful but not very kind of verifiable and trusted solution. So the important kind of note from my perspective is that whatever these models are built, they're either way designed to make money for the company that built them, right? Even if they're open source, kind of the underlying design is still how do we make money for the company that produced, even if they open it up. And so I think one of the important points is what is the optimization function, global optimization function for the system is. And I think the important is to have an alternative where the optimization function is individual user well-being and kind of economic success, right? So not a company success, but individual user success. No company has that as a value function, right, to make its users wealthier or the more well-being. And so I think that's why we need a different system that is actually ensuring this, and it's aligned with individual user being while still having the economic platform, right? It cannot be, this is not going to happen on itself. You need an economics and kind of capitalism forces to actually create this platform. So that's what we call user-owned AI, effectively AI that is owned by user but creates this economy around it. Now, there is a paradigm shift that's happening with this, right? So as I mentioned, as AI becoming the tool that we are interacting with computing, you're effectively transitioning from kind of the normal internet where you go to a browser, to an app, and there's a whole host of middleman processes that happen, right? There's aggregators like Google, Amazon. There's advertisement, payment processors, all of these different middlemen that are happening. And even I'll escalate that to even things like FDA. FDA is a middleman that effectively we outsourced our decision for evaluating what medicine is healthy for us or not, but it's a very average decision making, right? It's not taking any of the individual decisions into account. And so this is kind of how the current world works, right? We effectively outsourced most of our decision making about the whole kind of our life to other parties. And I think this transition where now we all can have an AI that is effectively as powerful and as smart as us, but actually can run 24/7, can split its kind of processing into thousands of threads. You can effectively now have your AI evaluating every single opportunity for you individually, right? So in this FDA example, instead of FDA getting all the information and deciding what's healthy or not for average American, you can have your AI assistant effectively communicating with every single pharmaceutical company, finding out what is needed for you right now, given your medical history, and effectively purchasing that, prepaying for research if needed, and getting you a specific medicine that's designed for you. And so same applies kind of across the board, right? So this actually very well fits into kind of this peer-to-peer communication, right? Because we're going away from this centralization of aggregators, right, of Googles and Amazons, of regulators and others, to really this peer-to-peer system where each individual now has their own assistant kind of making these decisions on their behalf and interacting, including for governance, right? Your assistant can effectively be voting on millions of decisions every day based on knowing your preferences. So we still need some place to actually interlink this, right? So we need a fabric, peer-to-peer fabric that actually interconnects this AI agents, services between each other. That's really what NEAR has been kind of positioning itself with all the technology we've been building to really enable this interconnectivity of peer-to-peer AI agents and assistants. So how do we make sure these agents are actually on your side, your AI assistant is on your side? Well, it's really important that you have a confidential kind of computing, because right now you're effectively uploading your data to someone. Even if you're using an open source model, unless you have your own hardware, you're effectively loading data to Together or somebody else, and you need to trust that they are actually handling it correctly. You want it to be verifiable as well. You want to know that the model they run is indeed the right model, right, as you're making decisions on this. We do want a monetization process, right? As new developers build new models or agents, there should be a way for them to make money so that there's economy of continue powering innovation. They need to find each other, discover each other. They need to interact and pay each other they need to support crypto and fiat. Crypto is obviously way faster and more natural for agents, but fiat is where most of the money and users are. And they need to access global liquidity, not just like financial, but actually, how do you route, medicine or get something from China and deliver it to your doorstep? So this is something we call agent network. It's effectively an evolution of internet, right, to AgentNet, where you effectively have this kind of secure platform where all these agents are living, the kind of agent hosting. Each individual user has their shared data and memory fully confidential, but there's ways for different agents to access it under different permissions. There's a way to find each other and to communicate and pay each other between these agents. So I'll specifically talk about how do we do the kind of the confidential part and verifiable part, because that is a fundamental unlock. So there's a lot of different methods for confidential computing and verifiable computing that have been around in especially in blockchain space, because this is where we are doing this, right? There's a ZK, which right now is, still too slow to actually apply to practical machine learning. And for privacy, you actually need to do it yourself, right? You need to do the proving yourself and computation yourself, which again, right now we don't have enough compute for state-of-the-art models to run locally. We have fully homomorphic encryption, which is also extremely slow, although there's some advances around like factorization, et cetera, to make it more performant. And the kind of consensus, right, where we run everything on hundreds of machines gives you verifiability, but it doesn't actually give you the confidentiality, which I think is extremely important, and we kind of, in blockchain, like forgot to do this for the most part. And so for a long time, there has been this idea of trust execution environments. This is where you trust the hardware to actually execute something inside hardware, and you have effectively a signature from the hardware itself that it wasn't possible, like the computation was done, and you don't have any kind of way to access it from outside whoever owns the hardware. And historically, this didn't work, right? There was a lot of kind of versions of this. There's very limited kind of hardware that kind of was known to be usable, and even then, there was like known side channel attacks. About, I would say, 8 months ago, the new kind of generation of Intel processors, as well as NVIDIA hoppers, enabled a mode of running this in an environment where you can ensure that both the CPU computation and GPU computation is indeed private. And this is kind of, again, only possible with like new Intel 5th generation Xeon processors that got like shipped in March or April last year, hoppers like kind of the second shipment of hoppers. And so it's actually only starting to become possible. Also, Blackwells are gonna be shipping now with this as well, including they're gonna enable intercluster confidentiality. So they will include NVLink, so the network connectivity as well between machines will also include in a single trusted zone kind of authentication. And so what this enables is effectively now you can run some computation on this. You can ensure that whoever owns a machine is not able to access it. And you also can ensure that only this computation was done on this data. And this is also a very unique kind of property that you don't get from many other approaches, which then in turn means that you effectively have nodes that are following the protocol, right? They're not actually able to sway over the protocol, and the only thing you need to deal with is liveness faults, right, where the owner of the machine can turn it off. So we built with Follow Network a kind of abstraction called confidential virtual machine, which abstracts specifics of the NVIDIA signatures and Intel signatures. We have the certificates published on chain, and so you're able now to kind of spin up this. It has NVIDIA drivers. It has it sets up the GPU and CPU in mode, and so now you can run, for example, AI inference inside this system, where you can actually run, DeepSeek, Llama, etc., and neither the owner of the machine, the model provider, us as software developers who build the software are able to access what's happening inside. Now, on top of this, you can build a system where I'm, as a developer who built a new model or agent, can effectively upload the encrypted weights, encrypted model weights, and the only way to decrypt them is actually to get them inside this confidential VM, right? So they are not decryptable outside, and the only kind of decryption key is available inside the confidential VM. For key management, there's like additional things needed because there are side channel attacks on TEs, and to effectively avoid extraction of key information, you need to use this approach called oblivious RAM, as well as you can use multi-party computation to kind of distribute the key material as well. But the idea is now you can effectively have, somebody can join this network and effectively get the key by effectively proving that they are part of they running software inside the confidential VM, proving it to other confidential VMs, get the key, decrypt the weights, and now be ready to serve the model, right? So it kind of creates this network where more nodes can join and exchange the keys. Again, with MPCs, this actually gets even easier where you don't need the interactive protocol. So now, on top of this, you can build then a monetizable confidential inference, right? Where you can effectively have model weights uploaded into this confidential VM, and you are able, as a user, now to effectively open up a payment channel with the system. Say, hey, let's say I'm going to spend $10 worth of inference credits on using this model. And then with this payment channel proof, you then go to this VM, you establish a fully encrypted TLS connection that the only certificate is available inside this individual CVM for you individual session. The certificate is going to get flashed after the session as well. And you prove that you opened this payment channel, and now you can run inference, right? So the GPU is now cranking, outputting your tokens. You can stream them back. And then with every streamed token, you also get effectively how much credits you've spent so far. And so, like, as you send the next request, you need to attach the last message from the confidential VM. And so then, when the payment channel is closed, for example, you finished the credits, or you want to release the money, that's when the payments then allocated to both the hardware provider and to the model developer out of this payment channel, right? So you have a smart contract facilitating now these payments. So benefit is, again, I'm as a model developer, I didn't need to have the hardware. I just uploaded my weights, and now anyone who has a hardware can effectively serve it. Nobody can see my weights, right? So, I mean, there's known examples of famous firms that gave their weights to somebody to serve that got stolen. And in this case, it's not possible. And you're getting paid effectively for this to be used, right? So, and the cool thing is, like, you're not responsible for how they're using it. You don't see how they use it. So you are not even eligible for permissioning it in any way. People can use it effectively as open source, right? They can run it on their own hardware. They can run it with any use case they want. Now, I mentioned one of the issues is actually somebody just turning off the machine, right? Because Bob, in that case, runs a machine. They don't know what's happening inside, but they can just turn it off. And so it's really important to actually have a proof of liveness, or we call it proof of response, a protocol that enables to effectively detect faults, liveness faults on the network. And so, I mean, the high-level idea is that we have effectively a overlay network of nodes which are all interconnected to each other, and each edge in this network itself is recorded on chain and is a payment channel. And so as user sends a request, effectively they provide the path in this network, and if anyone on this path doesn't respond back, doesn't relay back the information, effectively that edge, like the nodes that didn't get the response, needs to break the edge. And so the idea is, like, if for example, the service that you're asking is trying to censor you, right, for whatever reason, effectively the nodes that you're proxying through will start breaking edges with it until they, either break all the edges and then node is completely slashed and removed from the system, or it starts to actually respond to you. So there's a whole paper on describing this. It's a very interesting kind of generic protocol that's used for decentralized storage and other use cases as well. So putting all of this together, we can now get a fully decentralized confidential machine learning cloud, right? So it's a verifiable computing, fully confidential, that you can run, generic workloads that on CPU as well as, machine learning workloads on GPUs. So you can run like agent code, data processing, as well as machine learning inference, training, fine tuning, etc. On this, you have on-chain payment registry that facilitates this, and you have kind of this proof of response and kind of TLS encryption to provide you with privacy and liveness. So on top of this, we have agent hosting platform where you can just upload your agents, which kind of sit in this platform. And I mentioned the interaction protocol, right? So this is how does this agents actually talk to each other, pay each other, request data, and exchange information. And so that's the AITP protocol on top of this. So I'll just skip through, but I'll just finish on this thought, right? The AI right now has a lot of challenges. Control being one of the main ones, but it's more of a value challenge. It's not like, you don't have the issues with control until you do. But there's actually real challenges with like data privacy, right? Like as enterprise, you are having issues with uploading your data to third-party companies that you don't know how they handle the data, right? The energy consumption of these massive data centers, which these companies need to own because they're afraid their weights are going to escape, are effectively a massive issue, right? Like XAI in Memphis right now is like creating literal smog in the city because they need more energy for their data center. We have national level like data centricity, right? Like countries require data to live in their own in their own country, in their data centers. So we have all these national data centers now, which is then underutilized because all the models are sitting in these big data centers in Memphis and in Texas. And so we have like all of these actual challenges that are happening right now, and the way to solve them is really to unify this kind of compute power into this decentralized but confidential network where people can actually upload their models. And so that's really like decentralization here is really a solution to all of the real problems AI is having, and you just need to kind of apply a set of these pragmatic approaches to solve this. So AGI is almost here, and I urge everyone to make sure it's open and user-owned for all of us' sake. Thank you. And this paper. Yeah. So what makes Near better than competitive blockchain like ICP? So the important thing here, like Near, I kind of skipped the slide which was explaining the whole stack, but effectively, Near is not just a blockchain, right? It's a multi-purpose protocol for this like future of agentic network, and kind of blockchain is one part. It allows to do identity markets, settlement, coordination. We also have, the chain abstraction stack, which allows you to hold assets on every chain. It has an intense stack, which allows you to, move liquidity across, intense in the future. I mean, we're already working on fiat support, but it will support, I want some ore from a steel mine in Thailand to be delivered to, U.S. refinery, right? So like that's the kind of this unified liquidity layer that we want to bring together. And then we have this verifiable compute, effectively, like think of it as verifiable confidential EC2, right, that exists. So there's nobody who actually offers any of these, there's like different other protocols that offer feature here and there of one of these things, but like we actually offer this as a whole solution that enables you to build like actual things, right? So like I didn't mention, but we also have like now with this effectively EC2, you can run arbitrary computation, and then you can use blockchain and MPC to effectively verify that computation is correct, apply rule set, and then execute actions. So instead of trying to put a bunch of stuff into smart contract and kind of being very limited, you can now write arbitrary software with using Postgres database and fetch information from internet, run some ML loads, and then still execute actions as if it was a smart contract. So like that kind of level of breadth and functionality is not possible anywhere.
But in your thinking, the main application going forward for Near is machine learning, or?
I think main application for everything is AI. Just in general. There's going to be nothing that's not AI.
Wow.
and then
My statement.
and then like you'll be AI tools that AI is using, and that's the yeah. So like I mean again the examples I scroll through the demos, but we have things buying from Amazon. We have AI agents that write code for of AI agents, so like already recursively. Yeah, so there's a lot of already things that like people are actually doing that you would normally do.
This would be a great also, we're going to have a panel in the afternoon, so this is a great topic to also discuss on the panel. Thank you so much, Illia.
Thank you.
This was great. Yeah. Okay.